and welcome to our lesson on variables and constants, part 2, where we're working on translating words into algebraic expressions. What we're really getting at here is, can we model the world with mathematics? That's the whole point. We get problems all the time, and we have to decide as mathematicians, can we model this problem and use our model to help us maybe solve it, or at least predict what could happen in the future. So what we're going to do is practice that a little bit with some real expressions, and you should have been given an expression sheet by your teacher, or you could have downloaded it yourself, and we can follow along on this expression sheet with the directions. First of all, just a reminder from our Family Feud video that we did the other day. We have some important vocabulary. First of all, the word variable. Remember, we came up with the word variable. It is represented by a letter. It is a changing value, so it's something that can vary and change. 1 minute it can represent 5, the next minute it can represent 10. It also can represent an unknown. We don't know what it could be, so that's a variable. And I do have an example here. I have written x plus 3, x being the variable. We also have a constant, which is a value that doesn't change. So sometimes a constant, and in mathematics a lot of times we use constants as numbers. A specific number is a constant because 4 represents a quantity of 4 all the time. However, in science you might have other types of constants. For instance, you might want to say that the constant that we're going to keep is temperature. We're going to keep the temperature constant at this moment. It doesn't mean that temperature always stays constant, it just means it stays constant in that moment. So we have constants, we have variables. We also have expressions. An expression is just a mathematical phrase that we use to represent anything. It doesn't have to be a full mathematical, like what would you call a sentence, or an equation. That's the other word that we use. An expression can just be representing some quantities here and there. So an expression here, I have 3x plus 7 minus n. It's an expression, it's a mathematical phrase. The other word that we would use is an operation. And the operations that we're the most familiar with are addition, subtraction, multiplication, division, and exponents. Those are some of our operations that we're used to. There are more, there's different kinds of operations that happen, but those are the ones that we are most familiar with. Okay, so now looking at your expression sheet, you have quite a few on the expression sheet. Here's what I'd like you to do. I want you to look over your expression sheet with 2 different color, either markers or highlighters or whatever, okay? And I want you to code, or in other words, say that variables I'm going to mark red, for instance, and constants I'm going to mark blue, or whatever color, or you can use just pencil and say I'm going to underline variables and I'm going to circle constants, for instance. Now for me, I'm going to do a red and blue situation. So for variable, I'm going to mark that red. So I'm marking that for myself on my paper, and you need to do the same thing. Write variable at the top and then mark how you're marking a variable. And constant, I'm going to mark blue. So I'm going to mark that blue. Now I'm not going to mark operations right now. An operation is something I'm just looking for and going to represent. So what I want you to do now is stop the tape and look through your paper and either discuss with a partner or do it on your own. Look at every statement and see, can you find the variables and can you find the constants? Really think to yourself about what a variable is. A variable is something that changes, and it could change over time. The constant is something that's going to remain the same all the time. So really look through your examples, see what's changing and see what's staying the same. And then start the tape over, or start the tape from now, I should say. Start the movie from now, and we will go ahead and look and see what you think. Okay, let's take a look at our paper and see which are variables and which are constants in these statements. Now notice I added operations as something else to add to our word wall. Operations being add, subtract, multiply, divide, exponents. Basically operations is an action on a quantity or a variable or a value. Okay? Alright, so getting up to 2 times a number increased by 8. Well, the tricky part is when you say, what's the variable is a number. We don't know what number this is. It just says 2 times a number. So it could be 2 times 10, it could be 2 times 20, 2 times 30. It's an unknown. It's a possible changer. Well, where are there any constants, if any, in here? 2 times, 2 is a constant, but the word times is not. Times is an operation. It means multiplication. And when you say 2 times a number, you're saying you're multiplying it by 2, and 2 is a constant in that statement. And increased by 8, increased is an operation, but by 8 is a constant. Okay, and so if we start to, we'll be looking at some of these words like increased and times and start to look at what they might mean. Second, on number 2, 3 more than 8 times a number. Well, the variable, once again, we're not sure what this number is, but a number is our variable. So we could represent it by a letter. Now, in the first part of the statement, where are our constants? 3 more than, well, the 3 is definitely a constant because you're adding 3 when it says 3 more than, and then 8 times, you are multiplying with the times, but 8 is a constant. On number 3, 2 increased by 5 times a number. Well, once again, a number is the variable. 2 is a constant, and 5 is a constant. On number 4, twice a number decreased by 7. Well, the number, a number is a variable, but there are more than one constant here. You probably saw 7, but this one is also a constant. Twice means to multiply by 2. Doesn't mean sometimes multiply by 7 and multiply by 8. That would make it a variable. But twice means multiplying by 2. That's a constant. It's also kicked in as an operation. Twice being multiplying by 2. So there's sort of a constant and an operation kicked into that word. 1/4 of a number. Well, once again, we're starting to pick out a number as our variable. But the 1/4 is our constant. Of is an operation. All right, number 6, 9 less than a number. Well, a number, again, is a variable, where 9 is the constant. Less than is an operation. Okay, we have on number 7, a number. That's our variable. Well, how interesting. This one starts to give us a little bit more. 8 is a constant, times becomes an operation, and now we have the word is. Is isn't necessarily an operator, but it does mean equal to, or the solution of. So this is also an operation, basically. It's an operator, I would say, is an equal sign. It puts it into an equation. But negative 96 is our constant. The second of 2 numbers is 4 times the first. Their sum is 45. Well, what are our variables? There are 2 numbers. 2 in this case isn't a constant. It's talking about 2 different numbers. Maybe one is 10 and one is 15, or one is 17 and one is 32. It's talking about 2 numbers, so there's actually 2 variables in there. Where it says the second of 2 numbers is 4 times the first. So really, the second number is a variable and the first number is a variable. There are 2 of them in there. There's 2 numbers in there. Now our constant is 4 and another constant is 45. So looking at this statement here, there is a lot of different words in there, and you have to be careful. Just because they're written out, sometimes they're a constant, sometimes they're not. And this one's really tricky because and the second doesn't mean 2 necessarily. In this case, it means 2 variables, but it's referring to those unknowns. Okay, so that one's kind of complicated. Taking a look at number 9. A basketball player shot 70 times. The number of missed shots is always 6 more than the number of baskets made. Well, what things in here are variable? What could change? Well, first of all, the number of missed shots is a variable. We don't know how many shots he missed, or she, and it says it's always 6 more than the number of baskets made. That's also a variable. We don't know how many baskets are made. We do know that the 2 of them depend on each other. The number of shots you made is going to depend on the number you missed. For instance, if you take 10 shots and you miss 4, well, then you make 6. But in this case, you don't know who they are or how many shots is made. So we would assume that those 2 are variables. The constants in here are 70 and 6 are the 2 constants that are available in that problem. Number 10, the sum of the angle measures of any triangle is 180 degrees. In a triangle, the second angle measures 10 degrees more than twice the first, and the third angle measures 10 degrees more than the second. All right, so if we're looking at variables here, what don't we know? Well, we can go to the constants. We do know that there's 180 that the angle measures sum up to. And it does tell you about the relationships between the angle measures, but does it ever tell you the actual angle measures of this triangle? And if you look closely, the answer is no. It doesn't ever say that. So really, the angle measures of this triangle, and there are 3 of them, to measure up to be a triangle, we don't know what they are. So our unknowns are the first angle measure in the triangle, the second angle measure in the triangle, and the third angle measure in the triangle. There are 3 variables in that problem, and we have a 10-degree, okay, twice. That means multiplying by 2. It's an operation and a constant because we're multiplying by 2, and it's going to measure 10 degrees more than the second. The rest of the information here is all operations and the relationship between the 2 variables, or excuse me, the 3 variables. So you have to look closely at that. Number 11, Kira has $15 in her savings account. She'll get $5 a week for an allowance. How much is in her account at the end of any week? All right, let's look for variables here. We do know for a constant that she has $15. That's a nice constant, and she gets $5 a week for an allowance. How much is in her account at the end of any week? There's your variable. So we want to know the amount that's in her account. We're not sure how much that is. Okay, so there's our variable. And then what we look at says if she'll get $5 in a week for allowance, how much is in her account at the end of any week? When we started with $15, there's another variable in here that's kind of hidden, is how many weeks? We don't know that. It says it will happen at the end of any week, but what are we talking? 15 weeks, 17 weeks, 32 weeks? I don't know. So you have to look closely at these problems to see what are the things that could change versus the things that are staying the same. Her beginning 15 is staying the same. She's getting $5 a week. That's the constant. But the rest of the stuff is changing. The amount in her account and how many weeks. We're looking at the last few questions. The perimeter of a triangle is 33 centimeters. The first side is 5 centimeters shorter than the second, and the third is twice the first. Okay, so first of all, we can pick out our constant right here. We know we have a 33 centimeters. We know we'll have a 5 centimeter. And then if you look closely at the rest of this, they're talking about first, second, and third. However, they're not talking about 1, 2, and 3, the numbers. They're talking about sides. And we don't know the sides of this triangle. A perimeter of a triangle is all 3 sides, but we don't know what they are. So then we're going to have to say, well, the first side, that's a variable. We don't know how long that is. The second side, we don't know what that one is. And the third side. But we do know the twice coming up. It means multiplying by 2, the operation with the constant in there. So we have some constants and some variables. We definitely have 3 different things that could change. On number 13, the length of a rectangle is 3 times the width. The perimeter is 120 meters. Okay, so 120, we know that that is constant. We also know that multiplying by 3, that 3 is a constant. But what don't we know? Well, we're talking about a rectangle, which has length and width, but we don't know what they are. So when we do that, we say, well, the length of the rectangle is unknown and the width is unknown. What you have to get into your head when you're looking at algebra is on some of these you can start to use common sense to think of what the possibility is. And you say, well, I can solve that, so therefore they're not variable. However, we're talking about translating from words into expressions and to turn it into something that could possibly change. Because sometimes you get this first statement, but you don't get the end perimeter. And so you have to leave them in terms of variables so that you can play around with different possibilities. Okay? Number 14, the Malarkey family has 2 plates of food at their house. Each guest that comes to their party brings 3 more plates of food with them. Okay, so the things that are changing each time, that you don't know how many and could change, how about the guests. We don't know how many guests are there. We don't know how many guests come, but we do know a constant is they have 2 plates at the very beginning. That's a constant. And then a party guest brings 3 every time they come with them. So the guest comes there. So that's going to change the number of guests, but so will the number of plates of food is a changing object as well. So the food depends on the guests, obviously, because if no one comes, you still have your 2 plates. But these 2 are the 2 variables, the things that are changing. Okay, the temperature in Grand Lakes was 34 degrees. The temperature dropped a steady 2 degrees per hour. Well, 34 degrees Fahrenheit's that beginning. So that one's going to stay constant. And we also know it's going to drop that constant of 2 degrees. So when we look at the variable, we ask ourselves, well, what was changing? This one's kind of easy to think about. The temperature is changing in Grand Lakes, but there's also something else changing or unknown and it's changing each time, and that is hours. We don't know how many hours this is going to be going on. So those are the 2 things changing. Before we do any more with this handout, we need to get a handle on what it means, how we can start to translate all these operations. You've been doing different operations and you've heard them in a lot of different ways in your classrooms up till now. So we have to get a complete handle on when we read words or when we find out words in the real world, what mathematical operation do they mean?